everyone, my name is Akshara. I am pursuing my education at Sri Chaitanya Techno School. I have immense pleasure in being at ISDC Conference 2025, Live in a Healthy Space, Future Space Forms. This would not be possible without my parents, coordinator Venkata Ramana sir, teacher in charge Naresh sir, and our principal ma'am, Mrs. Sunaina madam. And we are deeply thankful to the organizers of this competition. Live in a Healthy Space, Future Space Farms. This project explores the significance of space agriculture as a critical component of long-term space mission and extraterrestrial colonization. Space farming ensures self-sufficiency, reduces dependence on Earth-based supplies, and supports sustainable food system in environments like Mars and the Moon. Space agriculture is a practice of growing food in space environments such as on spacecrafts, space stations, or other planets. It involves the use of advanced technique to cultivate plants in microgravity and controlled environment. Resources like water, air, and light must be carefully managed. The aim is to ensure that astronauts can grow nutritious food during long-duration space missions, making space farming a vital part of sustaining human life beyond Earth. The need for space agriculture. Self-sufficiency in food for long-term mission, where transportation of food from Earth to space colony or other planet can be expensive and more difficult process. Rather than, we can adopt alternative method like growing the crop in that place. Challenges of transporting food from Earth to space, key to future Mars or Moon settlements. Key factors for growing crops in space. Growing crops in space presents unique challenges, but certain key factors play a critical role in ensuring successful crop production like light. Light is a major source for plant for photosynthesis. Where we can't available light is inconsistent in space colonies or other planets. By this, we can use alternative method like adopting artificial light such as LED. Water and nutrients is a major resource for the plant growth. Temperature and humidity has increased the high yield of plants. Microgravity is one of the factors for growing crops in space. Atmospheric conditions where oxygen and carbon dioxide are essential for plants' growth and we are provided in this area. Methods of space farming. Space farming involves innovative methods to grow crops in space like hydroponics. Hydroponics is a method of growing the crops without the soil, where we provide the nutrients in the form of water. Aeroponics. Aeroponics is a method where plant roots are suspended in the air, where the nutrients are obtained in the form of mist. As in this method, more oxygen can be available and plant growth can be more and more. Regenerative life support system is one of the methods of space farming. Vertical farming. Vertical farming is a method where plants are grown in a limited space in a stackled layer. Genetically modified crops. Genetically modified crops are nothing else modifying the crops genetically. By this way, the crops can be resistant in the harsh conditions and can grow in a better way. Closed loop system is also one of the methods of space farming. Water management in space. It is a critical aspect of supporting human life in space. The key strategies include water recycling and recovery. In this method, we recycle the waste substances into safe drinking water, where waste substances include urine, sweat, and atmospheric conditions, where we use distillation process, chemical treatment, and we convert waste substances into safe drinking water. Atmospheric control and water capture, water storage and distribution, water generation system, water for agriculture, wastewater management are the methods using waste management in space. Role of technology in space farming and water management. Growing crops in space requires specialized technologies to overcome the challenges of microgravity, limited space and the absence of soil. Some key technologies include hydroponics and aeroponics, LED lighting, environmental control system, Closed-loop life support system includes oxygen generation and nutrient cycles, artificial intelligence, AI and automation, robotics and space farming. Designing farms for Mars and the Moon. Designing farms for Mars and the Moon involves overcoming extreme environmental conditions, controlled environment agriculture, supplemented by artificial lighting. These technologies help create sustainable farming solutions essential for long-term human habitation on Mars and the Moon. Future of space agriculture. Bioengineered plants for harsh environments. Focuses on modifying plants genetically to endure harsh conditions such as extreme temperature, high radiation, limited water, and low gravity. Whole body edible plants. Farming has a cornerstone of space colonization. Crops suited for space farming will need to be fast growing, nutrient dense, and capable of thriving in artificial conditions with low gravity and limited sunlight. Benefits of space agriculture: reducing dependence of Earth for supplies, sustainable food system for space mission, innovation for Earth agriculture inspired by space farming. Conclusion: space agriculture is crucial for the sustainability of long-term space missions and future colonization efforts on other planets. Space agriculture enables the cultivation of food in closed-loop, controlled environments, allowing for self-sufficiency and reducing dependence on Earth for supplies. This field of research involves developing resilient, high-yield crops and innovative farming techniques. Thank you.